Have you ever stopped to ponder if there might be a solution to the world's clean energy problem that we're overlooking? Our world is at a precipice, teetering on the edge of an energy conundrum. We're in a race against time, battling the ticking clock of climate change and the increasing demand for energy. The truth is, our current energy sources are simply not sustainable. Fossil fuels, such as coal, oil, and gas, are finite, and their extraction and use contribute massively to global warming. In our quest to find cleaner, more efficient energy sources, we've turned to renewables like wind, solar, and hydro. And while they've certainly made strides in reducing our carbon footprint, they're not without their limitations. Wind and solar energy, for instance, are dependent on weather conditions. No sun, no solar power, no wind power. And hydro? Well, not every place has a river or a waterfall to harness power from. Moreover, the energy density of these renewables is relatively low. This means we need vast areas of land to install enough wind turbines or solar panels to generate significant amounts of power. This presents another set of challenges, from land availability to potential disruptions to local ecosystems. And then there's the issue of energy storage. Storing energy generated by renewables for use when conditions aren't ideal remains a significant challenge. Current battery technologies can't quite keep up, and we're still a long way from a solution that can store large amounts of energy efficiently and cost-effectively. So we find ourselves in a bit of a pickle. We need an energy source that's clean, efficient, reliable, and sustainable. One that doesn't contribute to climate change, doesn't rely on specific weather conditions or geographical features, and doesn't require vast tracts of land. What if we told you there's a potential solution? One that's been under our noses all along. It's called nuclear fission. Nuclear fission may sound complex, but it's actually a simple process we can explain. Imagine a bustling city filled with millions of tiny, individual units, each one buzzing with energy. Now picture one of these units, an atom, splitting apart. This is the basic concept of nuclear fission, where an atom, typically uranium or plutonium, splits into two smaller atoms, also known as fission products. When this split happens, there's a sudden release of a vast amount of energy. It's like a microcosmic explosion. To give you an idea of the magnitude, a single gram of uranium during fission can unleash energy equivalent to burning 3 tons of coal or oil. That's the efficiency of nuclear fission for you. Now, you might wonder, how does this atomic split occur? The secret lies in neutrons. When a neutron strikes the nucleus of a uranium or plutonium atom, it causes that nucleus to become unstable and split, releasing more neutrons and energy. This triggers a chain reaction, with each released neutron causing more fission, generating a continuous energy release. Consider this energy as the lifeblood of a nuclear power plant. It's harnessed to heat water, produce steam, and spin a turbine to generate electricity. The potential of nuclear fission is immense. It's not just about the quantity of energy it can produce, but also about its quality. Unlike fossil fuels, nuclear fission doesn't produce greenhouse gases, so it's a much cleaner energy source. Moreover, nuclear fuel is incredibly dense. A small amount can produce a large amount of energy, making it a highly efficient energy source. And unlike renewable sources like solar or wind, nuclear power doesn't depend on weather conditions. It can provide a consistent, reliable energy supply round the clock. So, if nuclear fission is so powerful and efficient, why aren't we using it to solve our energy problems? As promising as nuclear fission sounds, it comes with its own set of challenges. Firstly, let's consider nuclear waste. When a nuclear fission reaction occurs, it creates byproducts that are, unfortunately, radioactive. These byproducts, or waste, remain hazardous for thousands of years. Disposing of this waste safely and responsibly is a significant challenge. It must be contained and isolated from humans and the environment for an incredibly long time. Currently, this waste is stored in specially designed facilities, but these are not long-term solutions. Then, there's the potential for accidents. While nuclear power plants are designed with numerous safety measures, the consequence of a failure can be catastrophic. We've seen this in the past with incidents like the Chernobyl and Fukushima disasters. These accidents released harmful radiation into the environment, causing long-term health issues and environmental damage. Furthermore, these incidents have helped fuel public fear and skepticism about nuclear energy. Many people associate nuclear power with images of mushroom clouds and radioactive monsters, thanks to pop culture and the media. This fear and distrust can make it difficult to gain public support for new nuclear projects, even if they can offer solutions to our energy problems. In addition to these hurdles, there are also political and economic challenges. Building a nuclear power plant requires a significant upfront investment. It also requires navigating complex regulatory landscapes and international treaties designed to prevent nuclear weapons proliferation. Finally, we must acknowledge the issue of finite resources. Uranium, the fuel for most nuclear reactors, is not unlimited. While it is relatively abundant now, we could eventually face a supply problem if nuclear energy becomes the primary source of power worldwide. Despite these challenges, many believe that the benefits of nuclear fission could outweigh the risks. The potential for a nearly limitless carbon-free energy source is a tantalizing prospect. And with advances in technology, we may be able to overcome these obstacles and unlock the full potential of nuclear fission. Nuclear fission isn't a far-off concept, it's a reality that's closer than we think. We're living in a time of unprecedented innovation and technological advancement, and nuclear fission is no exception. Scientists and engineers around the world are constantly pushing the boundaries of what's possible in this fascinating field. Let's take a look at some of the exciting developments. One of the most significant advancements in recent years is the development of small modular reactors, or SMRs. These compact powerhouses are designed to be built off-site and then transported to their final location, reducing both construction time and costs. They also offer increased safety as their small size makes them less prone to catastrophic failure. Meanwhile, research is ongoing into fourth-generation nuclear reactors. These cutting-edge designs promise to be even more efficient and safer than their predecessors, with features such as passive safety systems that kick in without human intervention. Scientists are also exploring the use of alternative fuels. Thorium, for example, is being hailed as a potential game-changer. It's more abundant and safer to handle than uranium, the fuel currently used in most reactors, and it's much harder to weaponize, reducing the risk of nuclear proliferation. But it's not just about the technology. There's also a growing recognition of the need to address the social and political challenges that come with nuclear power. Efforts are being made to increase public understanding of nuclear fission and to develop transparent, accountable processes for dealing with nuclear waste. The challenges are indeed significant, but the potential rewards are enormous. Nuclear fission could provide us with a virtually limitless source of clean, carbon-free energy. It could power our cities, fuel our cars, and drive our industries, all without contributing to climate change. The future of nuclear fission is bright, but it's a path we must tread carefully. It's a journey that will require the best of our scientific knowledge, our technological skill, and our ethical judgment. But if we can navigate these challenges, the payoff could be a world powered by clean, sustainable, and safe nuclear energy. We stand on the precipice of a clean energy revolution, and nuclear fission could be the key. Imagine a world where electricity flows like a river, clean, constant, and abundant. A world where the lights in every home are powered not by coal or gas, but by the splitting of atoms, a process known as nuclear fission. This isn't just a dream, it's a future that nuclear fission could make possible. The potential impact of this technology on the global energy landscape is staggering. With nuclear fission, we could generate immense amounts of power, enough to meet our growing energy demands and then some. Yet the beauty of nuclear fission extends beyond its raw power. It's also incredibly clean. Unlike fossil fuels, which spew greenhouse gases into the atmosphere, nuclear fission produces no carbon emissions. In other words, it's a way to generate power that doesn't contribute to climate change. Imagine the transformation this could bring about. Coal plants, once the backbone of our power grid, could be replaced by nuclear fission plants. Cities, once shrouded in smog, could enjoy clean air, and our planet, once threatened by rising temperatures, could start to heal. But it's not just about what nuclear fission could do for us today, it's also about what it could do for future generations. With nuclear fission, we have the opportunity to leave a legacy of clean, sustainable energy. We have the chance to give our children and grandchildren a world that's not just surviving, but thriving. The world's clean energy problem might seem daunting, but with nuclear fission, we have a powerful tool at our disposal. The question is, are we brave enough to use it?